Okay, we have another example of mixed factoring practice. We have a trinomial 8m cubed minus 10m squared minus 3m. So a couple things you notice. You probably notice that the highest exponent is 3, but it's a trinomial. So we're kind of wondering, okay, if we have 3 terms, why do we also have a cubed? Usually we only see cubes with binomials. Let's recall our helpful factoring polynomial flowchart. And remember, the first thing we always do is remove the GCF. So if you notice, every one of these terms contains an m. So my GCF is the m. So once I factor out the m, I'm left with the trinomial 8m squared minus 10m minus 3. So I have 3 terms. It is not a perfect square trinomial because it begins with an 8 and ends with a 3. Neither of those are perfect squares. So I'm going to use my AC method. So what I need to do is multiply a times c. So for my a, I'm using 8, and my c, I'm using negative 3. That's a product of negative 24. And then I want to make a list of all the factors of 24. Now, I need them to add up to negative 10 in the middle. So you might be thinking, possibly 2 and 12 if I make one positive and one negative, and then possibly 4 and 6, because 4 plus 6 is 10 also. But remember, I need to multiply to a negative 24, so one number has to be positive and one has to be negative. So it has to be the 2 and the 12. Because if I do the 4 and the 6, they won't add up to 10 unless they're both negative. They won't add up to negative 10 unless they're both negative. But I need one positive and one negative. So my 2 is positive and my 12 is negative. So I'm going to rewrite my trinomial as a 4-term polynomial. So I break up the negative 10m and I make it plus 2m minus 12m. Split it down the middle. Look for a GCF. So in the first 2 terms, my GCF is 2m. So I have that first GCF of m on the outside, and now I'm going to need a bracket to just nest everything in their own grouping symbol. And now I'm going to take out the GCF of 2m, and that leaves behind 4m plus 1. Now, in the second pair of terms, since the lead coefficient's negative, I need to factor out a negative GCF. And between 12 and 3, the GCF would be negative 3. So that's going to make a sign change, but hey, look at that. Now my binomials match. I have 4m plus 1 in both spots. So that's good. That means I'm on the right track. That means I'm going to finish this and I'm most likely going to have the correct answer. So the 2m minus 3 make up one of my binomials, and the matching binomial 4m plus 1 is going to be the other one. So I have the first GCF m on the outside. Then I have the binomial 2m minus 3, and then the binomial 4m minus 1. I invite you to check this. I would start by multiplying the 2 binomials first using FOIL, then distribute the m, and you will see your original problem.